So, can everyone see my screen? Just confirming. Great. So I will be pretty quick here. I know we only have 15 minutes. I'll give a quick overview about Nomic, talk a little bit about our strategy around open source, and specifically open source embedding models, and then give a kind of a quick dive into what we believe to be the future of how people interact with embeddings and how people work with embeddings. So Nomic, we're an AI product studio based out of Manhattan, New York. Our headquarters is out in the Flatiron. Here's a nice, lovely picture of or what we see every day when we walk over to lunch. So we're behind the popular open source embedding models. I'm sure many of you have probably used them, and the data infrastructure platform Atlas. Our mission is to build accessible and explainable AI systems. Just a little bit of kind of an overview about sort of some of the achievements that we've had. Our platform has over 30,000 users making data sets and using us as their data layer for their embeddings and unstructured signals like text and PDF, etc. Our open source presence is gigantic. Our open source embedding models are some of the most popular in the world. We have over 50 million downloads across platforms like Ollama and Hugging Face. I think we're the top model in Ollama and one of the top models in Hugging Face. And our open source community editions of our softwares have over 250,000 active users. Um, and people trust us in production as well. We're used by top enterprises, our Atlas data platform, for things like being their AI native data layer and our data analysis capabilities around our Atlas platform. And we're backed by some top investors who also trust and believe in the theses that open source is going to conquer all, and an open source strategy to building a business is actually feasible. So, a little bit about us and a little bit about Nomic Embed. I'd ask for a show of hands here, but obviously I can't see anyone. I usually ask people, how many of you guys have used our embedding models? Our embedding models are, as I said, are some of the most popular in the world because they're open source and they're truly open. What does that mean? That means when we release an embedding model and we release an AI model at Nomic, we release the model with the code fully open, the weights fully open, and most importantly, the training data, the secret sauce that allows you to go in and actually replicate the model. We have a few families of models that we work on. Some of which we actually released in the last couple of weeks. We have text models, image models, code models, and multimodal models. So our text model families, they're multimodal and aligned, which means you can use the text to search over images, images to search over the text. We have very, very high penetration in terms of distribution of these models, and they're free to use. You can just go on, download them. You don't have to talk to us. But if you want to productionize them or you want some help around these things, that's how we make money as a business. Um, and our papers around these models, they involve a lot of innovative work on the data front. That's kind of the secret sauce in training high quality models. When you're not a gigantic lab that has hundreds of thousands of GPUs, are accepted at some like top venues. If you want to learn more about Nomic research and how we think about building AI models from scratch, you can check us out at nomic.ai/research. One thing I'll highlight as well is we have a really popular model that was released last week that's gotten lots of traction, which is our Nomic Embed Multimodal. This is a completely open source 7 billion parameter state-of-the-art multimodal document embedding model. So it embeds documents, PDFs, images, screenshots, and allows you to do like a massive scale retrieval over top of them. So you can have a million PDFs and search over them and find things buried in tables and other sections. The model is completely open source. You could also use it with our Atlas platform. Um, so it's a little bit about us and our sort of stance on embeddings. We really believe that embeddings are going to be the atomic unit that databases operate over in the future. Every single piece of signal in the world is going to be embedded because embeddings are how computers communicate with each other semantically. That's how you send over meaning over top of the wire. Um, and why the impact of what we do. We were the first ones to actually build a open source embedding model that beat OpenAI's top models. This is about a year and a half ago now. We think very deeply about the practical applications of the models. We don't just say, we want to maximize the benchmark the benchmark on the leaderboard. We think about when people actually put embedding models in production, what do they care about? If they want to do large batch inference workloads, they need models that are small, models that are compressed but still high quality to be able to generate billions of embedding vectors over top of their data set. When people do retrieval, do you really need a 7 billion parameter model to, do retrieval in your web app? Probably not, depending on how sensitive your use case is. How do you go in and make sure that when you're storing these embedding vectors, those embeddings are actually something that are cost efficient to store? From the ground up, when we build models, we don't just think about how do we make the models to be the best possible in terms of performance, but how do we make them be the best possible in terms of production use cases with things like vector compression and strong inference time properties properties like Matryoshka resizability. You can resize the embeddings at the end. And one of the other things we'll say here is, we were operating as sort of a small, nimble team working on the sort of cutting edge innovation. We at times only had 16 H100 and scaled up to, a couple multiples of that. And that caused us to innovate. We were able to go in and do a lot of this innovation that allowed us to beat top labs in terms of embedding model quality because we were working under these constraints. Code and kernel optimizations that were needed to go in and actually be able to create the batch sizes required to increase model quality and obviously higher quality data sets. In the process of training our first models, just a quick anecdote, we spent basically, I think it was 9 months for the first iteration cycle. Two of those months were poking around in the code, and 7 of those months were staring at the data sets. It's a good thing that we have tooling built out for that and for staring at data sets really well. Um, and then here's some nice vanity metrics for I think this is like a pull from last week. Sorry, last month. Um, I'll say here, we don't just, do a bunch of open source stuff and hand it out to the world for free for no reason. It generates us a pipeline for our main product, which is our Atlas platform. Atlas is a embedding powered data platform that makes it really easy to operationalize millions of PDFs, images, and embeddings. So basically, the way it works is it's a data layer that's embedding native. It's built over top of common data formats like Apache Arrow and Lance. It allows you to ingest all of your text, images, embeddings, and allows you to interact with that with visual analytics and something called a data map. We don't just focus on algorithms on embedding models. We also focus on algorithms on embedding spaces. So we have advanced algorithms for topic modeling and dimensionality reduction that allow you to go in and really understand your large unstructured data sets and operationalize and take action on them. So analysis is one thing, but also putting them into production applications. So we have businesses powering hundreds of AI agents internally over top of our retrieval layer in Atlas. I'm going to use the rest of this time to kind of give a quick demo and overview of some of the capabilities of Atlas, specifically around working and interacting with embeddings. Can everyone still confirm they can see my screen still?
Yep.
Cool. All right. So when you hop into the product, what you'll see here is it's a data lake layer. So you go in, you drop in, and I'm going to show you a quick example of using a data set of text and using our open source text embedding models under the hood to power it. So you can go in, you can get data in in many different forms. One form is just a file upload. You can upload CSV files, for example. Here, I'm actually going to upload a data set of airline passenger reviews. So this is a data set that has a couple of columns. One column here is an unstructured column, which is text. Atlas is powerful when you're working with data that's unstructured, text, PDFs, images, raw embeddings if you're training your own AI models internally. And what we're going to do is actually we're going to go in and generate embeddings over top of all of these columns, and then use Atlas to be able to go in and analyze the data set in the data map viewer. And I'll explain what that means in a second. But really easy to get data in. I'm gonna go in, kick this off, and then this will take about 5 minutes to go in and fully index a data set and get it ready for retrieval, embedding operations. You'll have embeddings generated over top of the data set. And you get sort of a viewer like this. So this viewer you're seeing right here, it's called a data map. What you're seeing is actually a visualization of the underlying data lake that I just uploaded into the data set in Atlas. The way you read these is that in a data map, every single point is a row in your data set, so a PDF page or a text document. And then 2 points are close together if they're talking about the same thing. What does that mean? It means that the embeddings of the underlying points, so every column in your data set, Atlas enriches it with embeddings. It could be Nomic embeddings or anyone else's embeddings. And it is showing you the semantic properties and the semantic relationships between data points in your data set. Automatically, it uses our advanced topic modeling algorithms to go in and label regions of your data set. So, for example, all of the conversations about legroom are in this region of your latent space in your data map. There's several powerful tools that we expose when you're going in and using Atlas to analyze your data set. You can go in here and use our vector search functionality. So you can say here, find me all the negative reviews. And what this will actually do is it'll run a vector search over top of your entire data set and then highlight the regions of your data set that have concentrations of negative reviews. Let's say about food quality. Let's just dig in specifically food. And as you can see here, this is the big cluster here in the embedding space in the vector search index that's talking about food quality. Um, One of the other really powerful things that you can do with Atlas, apart from just really diving deep into your large data set and understanding what's going on, is all those operations you can actually do via an API. So you can productionize, for instance, retrieval and agent and RAG applications over top of it. One other thing that I'll highlight here is we actually have a native data agent as well that uses and operates over embeddings with vector searches and other operations to allow you to perform really complex analyses over top of data modalities like text, PDF, images, other data stores. So I could actually ask here, like what are the main modes of negative feedback in this data set of airline reviews? This is actually going to activate an agent that's going to figure out the right queries to pull in over top of the data set. Oh, made an error. It recovered. And pull in the right queries that will go in and correctly tell you about regions of the data set that you might care about. So this things that it seems like this issue with food quality, compare and contrast the issues with food quality and comfort. And to do this, it'll actually go in and create vector searches of these various data regions to examine the various differences in like quality. The other thing I'll highlight here, so this is a great data set that's of raw text. That may be something you'd see operationally in like a real life work environment. A lot of our customers use us also for analyzing their embedding spaces. So when you're an AI team and you're iterating on an AI model, it's really important to be able to have qualitative feedback when you're iterating over top of your model quality. What does that concretely mean? So let me give you an example here. This is a data set of actually images. So every single data point here is an image, and then 2 points are close together. If those images are similar in the embedding space of a neural network that was trained to do image classification. One thing that you'll see here is that because the neural network's not perfect at classifying images, there's errors. How do those errors manifest? Those errors manifest at the decision boundary here on the boundaries between these classes. And you can actually see here examples of where the model predicted that this was a 0, but the actual label was an 8. And Atlas is really powerful to use to look at decision boundaries of these regions. And one thing you can also do here is use analysts to query over top of this embedding space as well. What are some of the model errors? And so they'll actually go in, find those model errors by doing the right thing. It's going to go in and realize, oh, I find model errors by finding differences between labels and predictions. And then you can see here automatically organizing these kinds of things for you. Give me some specific examples. And if whatever version engineers shipped a couple of weeks ago is working correctly, it should be able to actually cite these regions as well. So this kind of gives you an idea of kind of some of the powers you can do when you have strong visual analysis tooling over top of your embedding spaces. Alrighty. One thing I'll say here, if you want to try Atlas, you can go in and pull up this QR code. Scan this, it'll get you into the product. If you want to reach out to us and connect with us on LinkedIn, here's a QR code as well. You can give that a scan and reach out to us. Thank you so much for listening. I hope you learned something new about open source embedding models and the future of how everyone in the world is going to interact with their data sets.
Andrew, amazing. Love it.